Okay, I want to give you just a little overview of how I have this Excel spreadsheet data example set up because it might take some explaining. So this is all last year's data, first of all. And if you aren't able to do the lab, then you can just use this data for your memo. But what would be better is if you could go collect your own data and put it in here. So I have a bunch of formulas in here so that you don't have to manually count everything. So first of all, let me just kind of show you how that works. If I click on this cell, you'll see the formula up here, and it's summing cell D6 through D21. So that's great, except that if you go in and you add your own data for transect 1, and let's say you only had 3 or 4 trees, because I shortened your transect this year compared to what they did last year, so they basically did a transect that was 3 times the length of what I had you do this year. But we were in groups and not doing it independently. So you may only have 3 or 4 trees, right? So just adjust this, come in here and highlight this, and then click just the cells that you entered your data for, and then hit enter, and it'll adjust it down here. All right. So I'm going to get rid of that. That holds true for almost everything that you see a calculation in here. So we have sum of the number of trees alive and so forth. Over here, bull scorch proportion, I have an average of the bull that was scorched, crown scorch proportion, and so forth. And it's important to, let's see, when we get over here, I added these in, probability of mortality. This is important. It's a little bit more complicated of a formula here because we're saying, okay, we're going to sum this and then divide it by just the trees that were alive. So this formula here says count if cells D6 through D21, which is this grouping here, count if they're given a value of 1. So in this case, there was only 2. So he said, all right, give me the average here and divide it by 2. All right, and so it's 0.45. So of the living trees, you have just under 50% probability of mortality. I hope that makes sense. But that's what this formula here means. And I did the same thing over here for 60% chance or greater of dying. So I went through and I just had to make this data up because we didn't do these 2 columns last year. We didn't do that. So I just made this stuff up. So if you're doing the memo, know that column K and L are completely bogus. But I just went in and I said, okay, this tree is probably going to die. Kind of based it off of that. And the same thing here, I said, okay, sum the ones that were 60% or greater. So give a 1 to everything that has a 60% chance or greater of dying and a 0 to everything else. And then you can sum that and count it out of just the ones that are still alive. So that's an important thing to think about is on all of these, we care about the chance of these trees dying out of the ones that haven't already died. So don't average it over every tree that you counted if some of those trees were already dead. That's pretty important. So the main thing here, folks, is that go in here and look at the formulas that I put and then check the reference. And so like E6 through E21, if you don't have that, like you need to go through and go, okay, so of the post-burn mortality, if they had a 0, that's what we divided them by. So you need to go through and just change it to match your column and rows to get your specific cells of what you're looking at. So I did that for each individual transect, and then down here at the bottom I provided some kind of summaries, and so average of those 4 transects averages, and then average of these 4 for average percent trees have a 60% chance or greater of dying. So this is just the summary information from the different transects. If you have any troubles with this, just reach out and ask.